Welcome to homework.
Okay, so question is, we need to use an algorithm given as this, and we need to find the transitive closure of the relation between A, B, C, D and E, where A is given as this relation. Okay, so let's form MR first, that is the matrix of relation. So MR, now here we have 5 elements, so we'll have 5 by 5 row, 5 rows, 5 column. Okay, and this is the relation given to us. So let's take this A, B, C, D and E here, and similarly A, B, C, D and E. Okay, so there is no A to A relation, so 0. A to B, we don't have 0. A to C here. Then we don't have any other relation from A, so we can write 0 directly. For B, we have B to D and nothing else. So for B to D here, and rest will be 0. Similarly for C, we have only one relation, C to A, so that is here 1 and rest is 0. Then we have D to B, so D to B is here 1 and rest is 0. And then we have E to D, so E to D, so D is here and E is here, so here we have 1 and rest is 0. So this is MR. So first step is we have to assign the MR value to A, so this is nothing but equals to A that we have to consider, and then this A value is given to B, so this is B as well initially. Okay, so now we'll enter the loop and we'll start from 2 to n. So here 2 to n means we have to move till n elements, that is 5, and we'll start from 2 since we have already calculated 1 and 0th value. Okay, so first is we have to take here dot product of A and MR, and this is Boolean dot product, right? So A times MR, so A Boolean dot product with MR, and we have to assign this value to A only. So this is equals to, we have to multiply given matrix or obtain matrix this with its same value, since that is our first value, right? So let me quickly write it. Okay, then copying the same value again, since we are multiplying A with MR and initially A and MR are equal, so 0 0 1 0 0. Similarly write all the values. Okay, so now we are ready to take a Boolean dot product. Okay, so we'll multiply this with this value and taking a Boolean product. So 0 times 0 is 0, 0 times 0, here 1, and here also we have 1, so we can write, so that gives us 1 here, and the rest is again 0, so we can write this as 1, right? Since a Boolean operation, so 0 times 0 is 0 and 1 times 1 is 1, and adding 1 and 0 will give 1, adding 1 and 1 give us 1. Okay, similarly calculating the second value, so that is first row, second column. So here, since we have 1 in the fourth row and here we have 1 in the third column, so this will give us 0. Similarly calculating this will give us 0, this one will give us 0, and the last one will give us 0. Okay, so now second one, here we have 1 in fourth column, and again starting with here, so first one is in third column, sorry, third row, so this will give us 0. This is in fourth one, so here we'll get 1. Then we have 1 in the first row, third column, so again that is 0. This is again 0, and the last one is 0. Okay, so now calculating third row, so here we have value 1 in our third row and first column, so this will give us 0. Then this is again 0, right? So 0, then we have 1 here and 1 here, so this will give us 1. Then multiplying this third row with fourth column, so again we have here 1 and here 1, so that gives 0 because they are not multiplied, and the last one is 0 since its all values are 0. Okay, so this is the third row. Now fourth row, so we have value 1 in our second column. Here again the first column will give us 0, second column will give us 0, third column, here we have 1, but here we have in second column and here we have in first column, so that's again 0. Here the third row, and here we have 1 and that is 0. Then again we are calculating this on similar basis. We'll get here 1 we have in fourth row, and here we have 1 in fourth row, right here, but this value will become 0, so only we'll be left with this one. So here we have 1, and again this is 0. Okay, so we are done with first part of this, that is taking dot product, and then we have to take OR with B and A. Okay, that is union, right? B and A. So we have B, which is A initially, so we have to take union of this with this one or this one because all are same. So let's take, and we have to assign that value to B. So B will be equals to taking union of these two, since this is our A value and this is our obtained A value and this was B value. If we can see here, both were same. Okay, so taking union element wise, so here 1 0 is, let me write it, 1, then second is 0, then 1, then we have 0 0, so let's write 0 0. Then in the second row we have 1 here and 1 here, so that too will give us 1, rest will be 0. So here 1 and then here 1, right? In the third row we have 1 here, and in this third row we have 1 here, so this too will be 1. So 1 0 1 and rest will be 0. Similarly in this one, fourth row, we have 0 here, fourth row, so 0 1 0 1 0, and the last one will have only 1 in this one. Okay, so that's 0 0 0 1 0. Now this is our new updated B, and this is our A. Okay, so now this cycle repeats again, so we have to multiply this B with A using our same method like this, and we have to do it till 5 steps. So that is starting from 2, so this is one step, so we are now reached 3, now 4 and 5. So after doing that operation we reach our answer as, which is given as R star, or relation, closure relation. So that is equals to 1 0 1 0 0 0 1 0 1 0 1 0 1 0 0 0 1 0 1 0 and 0 1 0 1 0. Okay, so that is what we obtain. Now for B we are given here relation, so let me form our MR here only. Okay, and then using the same method we can find the closure relation of that as well, transitive closure relation. Okay, so here we don't have A relation with anyone, right, from A to nothing. So A here 0 0 0 0 and 0, right? A B C D and E. Then from B we are going to C, so here we have 1, we are going to E. Okay, and rest is 0. From C we can go to E, so from C, this is our C column row, we can go to E, rest we cannot go anywhere. From D we can go to A, so here we have 1 and rest is 0. And from E we can go to B. Okay, so from E we can go to B, and from E we can go to C, rest are 0. So this is our MR, and using the similar procedure the value of transitive closure for second one is equals to 0 0 0 0 0. Okay, and as we can see here, A does not go to anyone, so there is no transitive relation of A with any of the given values. The next is 0 1 1 0 1. Using the same method we can calculate these values. 1 0 0 0 0 0 1 1 0 1. Okay, so this is for B. Now for C, okay, so let's form the MR first, and then we can use the same method. So MR for this will be, A is going to B. Okay, so here we have A, B, C, D and E. Similarly A, B, C, D and E. So there is no relation between A and A, so 0. A is going to B 1, A is going to C 1, A is going to E 1, and rest is 0. Similarly B is going to A, so here we have 1, B is going to C and rest is 0. Then C is going to A, so 1, C is going to B and rest is 0. D is going to A, so 1 and rest is 0. And E is going to D, so 0 0 D and 0. Okay, so we obtain MR. Now again using the same algorithm as we have discussed earlier, we can find the transitive closure of C as 1 1 1 1 1. Okay, and the rest all the values are 1 in this case. Okay, so last we are left with part D. Okay, so let's have MR and of D. Okay, so for solution D, again we have A, B, C, D and E. Similarly A, B, C, D and E. Okay, so let's have that. So A is going to E, so 1, and rest it cannot go anywhere, so 0. Then we have path from B to A, so B to A, B to D, B to D, and rest is 0. Then we have from C to D, so C to D here, and rest is 0. Then we have D to A, so that is here, and D to C, which is here, rest is 0. Then we have E to A, so here, E to B, E to C, and E to E, and rest is 0. Okay, so this is our MR, and again using the same algorithm, that is assigning MR value to A and then assigning A value to B. Okay, so this is our first step, and then using for loop or any kind of loop that iterates it from 2 to n, where n is the number of elements here we have, and we start by taking Boolean dot product of mr and a, and then assigning this value to a, and then taking union of a that we obtained and the previous b and assigning it to b to update b value, and iterating this till n terms, we get the b value which we have to return, and that is our closure relation, and that is equals to, in this case, that is for d is 1 1 1 1 1, and rest all the values are 1 in this case, and this shows that we can reach to any point from any vertex, right? Okay, so that is our answer. Thank you.